Hello dear students, as you know that in the last class I have started about the application of the Biot-Savart's law, that is to find the magnetic field due to a current carrying conductor in the form of different geometries. In the last class I have shown you about a straight current carrying conductor and a circular coil. These were a mere repetition of whatever you have learnt in the higher secondary days with some advancements, although very minor. Today I will try to find the magnetic field due to a solenoid. So as you know that what is a solenoid? So a solenoid is formed when you wind মানে পেঁচানো, তারকে পেঁচাতে হবে, when you wind wires over a non-conducting material such as wood, bamboo of that particular form. মানে আমাদের কাছে একটা non-conducting material থাকবে. There is a non-conducting material, that is what we have. A non-conducting material, suppose this one, এটা হচ্ছে আমাদের একটা non-conducting material, suppose this is made up of wood or bamboo, something of that material, and over that some wires are winded, এখানে তারগুলোকে পেঁচানো হয়েছে এরকম ভাবে. So whatever is formed in this case, এই যে জিনিসটা তৈরি হচ্ছে এখানে, whatever is formed, that is called a solenoid. So like this. Now whatever I will do is that I will draw the axis of the solenoid. Solenoid এর একটা axis থাকবে. So I just next draw the axis of this solenoid by the dotted lines. So this is the axis of the solenoid. The next task is that I consider a very small element over here. So এখানে আমি একটা ছোট element নিচ্ছি. I consider a very small element of the solenoid like this. I consider a small element over here at a distance x from one end. Just excuse me for a minute. Okay, so now whatever we will do is that at a distance x from one end of it, we consider a small element dx. At a distance x from one end, we consider a small element dx over here. And suppose this capital P is the point of interest. Capital P is the point of interest where we like to find the magnetic field. Capital P হচ্ছে এমন একটা পয়েন্ট যেখানে আমরা ম্যাগনেটিক ফিল্ডটা বের করতে চাইছি. Capital P is definitely on the axis. This angle over here, and we should also join the two ends with this point P. এই দুটো এন্ড কেও আমরা জয়েন করব. These two ends also I join over here. Now these angles are, we denote these angles. This angle is theta 1. This angle, this one I call it theta 1. And this final angle over here, that is the two ends, the angle made by the two ends, this angle we call it theta 2. And the angle that is produced in between this angle I call it theta. এই অ্যাঙ্গেলটাকে আমরা থিটা বলছি. So please make a clear picture as much as you can do. এখানে যতটা ক্লিয়ার করতে পারো নিজেরা ক্লিয়ার করে ডায়াগ্রামটা ড্র করবে. So make a clear picture of this one about this theta 1 and theta 2. So basically theta 1 is the angle made by P with one end, theta 2 is the angle made by P with another end, and theta is the angle made by this small element. এই element যে অ্যাঙ্গেলটা তৈরি করে, the small element, this angle is theta over here. And the distance of this capital P point from one end of the solenoid, that is I fix the left end as my reference. So this distance is x0, that is up to the point P. এই point P পর্যন্ত এই ডিসটেন্সটা হচ্ছে x0. So these are the things that we should take care of. And one more, this distance is r. এখানে এই দুটো পয়েন্টকে আমি a আর b নাম দিচ্ছি. This point I call it a, this point I call it b. So definitely this BP distance, this BP is nothing but equals to R. I hope that you have understood everything about it. এইটুকু জায়গা তোমরা নিশ্চয়ই বুঝতে পারছো যে কি করার চেষ্টা করছি আমরা। So once this has been understood by you, এইটুকু জায়গা বুঝে যাওয়ার পরে let me now okay, just let me put up a heading over here: magnetic field due to a solenoid. Magnetic field due to a solenoid. Okay, this is my heading. Let me just put up an introduction over here. একটা ছোট করে introduction লিখে দিচ্ছি. Let us consider a solenoid. Let us consider a solenoid having small n number of turns, per unit length, number of turns per unit length. Okay, let us consider a solenoid having small n number of turns per unit length, each having radius a. Radius of the turns is a. Each having a radius a. প্রত্যেকটা radius হচ্ছে a. Each having a radius a, and capital I is the current, and capital I is the current flowing, and capital I is the current flowing through it, and capital I is the current flowing through it. Now what do we have to do? We have to calculate the magnetic field. We have to calculate the magnetic field at capital P. We have to calculate the magnetic field at capital P, which is at a distance x0, which is at a distance x0. I write this way: which is at a distance x0 from one end, which is at a distance x0 from one end of the solenoid, which is at a distance x0 from one end of the solenoid lying on the axis. We have to calculate the magnetic field at any axial point. We are interested to calculate the magnetic field at any axial point. Okay, so axis এর উপরেই আমরা বের করব. We will find it on the axis only. Now it is very interesting to note that, and for this particular purpose whatever we do is that, এবং এটার জন্য আমরা যেটা করছি সেটা হচ্ছে we consider a small element dx. We consider a small element dx at a distance x. We consider a small element dx at a distance x from one end. নিলাম আমরা at a distance x from one end. এবার আমাকে বলতে হবে এই যে এইটা হচ্ছে dx টা, this is that dx. Now how many number of turns are present within that? Number of turns within dx is equals to how many number of turns are there within that dx element? That is definitely n dx, because n is the number of turns per unit length. Per unit length এ কতগুলো টার্ন আছে? n number of turns আছে. Number of turns per unit length is n. So what is the number of turns within the element dx? So that is definitely n dx. So number of turns within dx is equals to how many? Is equals to n dx. Okay, এবারেতে okay, number of turns মানে number of circular turns, we may write it circular turns. And from the last class, that is in the last class, we have calculated that what is the magnetic field due to n number of turns. এর আগের ক্লাসে দেখো তুমি n number of turns এর magnetic field ক্যালকুলেট করেছিলে. That expression I write it on the graph. That was mu 0 ni s square. মনে পড়ছে তো? mu 0 ni s square divided by 2 times of s square plus x square to the power of 3/2, or you can write it simply, বা তুমি এটাকে সিম্পলি এরকমও লিখতে পারো, it is r cube লেখা যেতে পারে, r cube. You can write it r cube also. Mu 0 ni s square divided by 2 times of r cube. This expression has been calculated on the last class. এটা আগের ক্লাসে করে দিয়েছিলাম. For the case of a circular coil, please follow your last class. এর আগের ক্লাসটা ফলো করো. Please follow the last class. There you will find this expression, the circular coil. For a circular coil, just let me draw the diagram. This was the circular coil, and if this distance is r, এই ডিসটেন্সটা যদি r হয়ে থাকে, if this distance is r, this was x, this was a, you can definitely express r in terms of a and x. Definitely তুমি r টাকে a আর x দিয়ে রিপ্লেস করতে পারো, so it will be simply a square plus x square to the power of half. So this was the expression mu 0 I square. N is what? N is for n number of turns. If there is a single turn, then it is mu 0 I square divided by 2 times of r cube, or r cube you may also write a square plus x square to the power of 3 by 2. That is what you have written on the last class. এর আগের ক্লাসে লিখেছিলে তো r square is you see it is simply a square plus x square. So you may write it in terms of r also, you may write it in terms of x also. In today's class I follow this r methodology. আমি r টা দিয়ে লিখছি। এই এক্সপ্রেশন কোথা থেকে পাচ্ছি? This expression I have obtained from the last class, and in today's class I will be applying this, because the small element that I have considered, আমি যে small element টা নিয়েছি, এই যে small element dx টা, this small element, there you have many number of circular turns. This diagram I have drawn the turns spaciously. আমি তো টার্নস গুলোকে অনেক স্পেস দিয়ে ড্র করেছি, বাট অ্যাকচুয়াল ডায়াগ্রামে এত স্পেস থাকে না। they are very dense, একটার উপর একটা যাচ্ছে, they are very dense. So if you consider a small element over here, so then there will be a number of turns. তখন একটা ছোট এলিমেন্ট নিলে এখানে অনেকগুলো টার্নস থাকবে, there will be many number of turns, which is not in the present case because I have not drawn it densely in order such that my diagram is neat and clean. ছবিটা ক্লিন করার জন্য এখানে তোমরা এখন বলতে পারো স্যার এখানে তো কোনো টার্নই নেই, there is no turn over here. No, there are turns. I didn't show it on the diagram. The turns are dense, আরো ঘন আছে, but আমার সেটা দেখাইনি in order to make a clear diagram. So number of circular turn is this. So what is the magnetic field at P due to this element dx? So therefore magnetic field at capital P due to ndx circular number of circular turns, due to ndx number of circular turns. This expression I will borrow from the last class. এটা আমি আগের ক্লাস থেকে নেব, due to ndx number of circular turns. So this one I will write it dB. So dB equals to how much? This is mu 0. This one is ndx. This is the number of turns. Then it will be is square, and then it is 2 times of r cube. Here let me show the current. So this is the current flowing in the solenoid, current I. Excuse me. So this is the expression that I obtained over here, and I need to work with this. Here you see that there are two variables. এখানে দেখো দুটো ভ্যারিয়েবল আছে, r is a variable and x is also a variable. X is the distance, it is at my choice, so definitely x is a variable, and this capital R will also vary if I vary the position of this point P. So point P এর পজিশনটা যদি চেঞ্জ করি, or if I change the position of this element AB, এই এলিমেন্টের AB এর পজিশনটা if I take AB over here, আমি যদি AB টা এখানে নিই, so then you see that R is this distance and x is this distance, so definitely x and R varies. If I change the position of this small element AB, so then definitely the position of x and R will change. So here you have two variables, one is x and another is R. তাহলে এখানে দুটো ভ্যারিয়েবল আছে, একটা ভ্যারিয়েবল হচ্ছে x আর একটা ভ্যারিয়েবল হচ্ছে r, বাট আই নিড টু কনভার্ট ইট ইনটু সিঙ্গেল ভ্যারিয়েবল। আমাকে এখানে একটাই ভ্যারিয়েবল এটা করতে হবে, আই নিড টু, বিকজ ইউ ক্যানট ইন্টিগ্রেট দিস, বিকজ দেয়ার আর টু ভ্যারিয়েবলস, ওয়ান ভ্যারিয়েবল ইজ x, ওয়ান ভ্যারিয়েবল ইজ r, ইউ ক্যানট মেক এ টোটাল ইন্টিগ্রেশন অফ দিস, সো ইউ নিড টু কনভার্ট ইট ইনটু সিঙ্গেল ভ্যারিয়েবল। তোমার এটা সিঙ্গেল ভ্যারিয়েবলে কনভার্ট করতে হবে। This type of calculations we have done during the calculation of gravitational potential due to a shell in your first semester course. There also you see that there are two variables and we have converted it into a single variable theta. এখানেও সেরকম চেষ্টা করব, I will convert it into a single variable and then I will try to complete my task. This is suppose equation 1. Now you concentrate on the figure. So from figure you will find tan theta. Let us try to find tan theta from the figure. Figure থেকে tan theta টা বের করো তো কত আসে? What is the value of tan theta from the figure? So the value of tan theta from this figure is perpendicular by base. So the perpendicular over here is this one. This is nothing but the radius. এটা তো radius টা. This is the radius. You may mark it over here. This is the radius of the solenoid. So this one is a and perpendicular by base. Base is nothing but this distance. The total is x0 and this one is x. Total এখানে x0 আছে and this one is x. dx is negligible. So perpendicular is nothing but x0 by x. So I can write it safely a divided by x0 minus x. Okay. The base you understand, here to here the distance is x0, but from here to the element it is x. So how much is this? এইটা তাহলে কত? This is definitely x0 minus x. dx is negligible small. So from here you may find the value of x0 minus x. The value of x0 minus x is a cot theta. The value of x0 minus x is a cot theta. And if I take a dx from here, so it is minus of dx is equals to minus a cosec square theta d theta. So this will simply give you dx is equals to a cosec square theta d theta. That is the expression of dx. Let it be equation number 2. And also from the figure you will find sin theta. What is the value of sin theta? Sin theta মানে perpendicular by hypotenuse, লম্ব by অতিভুজ, perpendicular by hypotenuse, so that is a by r. So এটা ভ্যালুটা হচ্ছে a by r. So এখান থেকে আমরা r এর ভ্যালুটা বের করে নিচ্ছি. So r becomes a cosec theta. R becomes a cosec theta. This is equation number 3. Right? So let us put 2 and 3 in 1 using 2 and 3 in 1. Using 2 and 3 in 1. If I use equation 2 and 3 in 1, then actually what happens? Excuse me. So dB equals to, so under that case dB will become mu 0 small n a square. Now dx you replace with a cosec square theta d theta. Dx you replace with a cosec square theta d theta divided by r cube, that is a cube cosec cube theta. So this a square a gets cancelled with a cube and this cosec square theta gets cancelled with this cube. So finally you have dB is equals to mu 0 ni into sin theta d theta. That is the final expression. So now you see that it is a single variable equation and you can easily integrate this out. So therefore what is the total magnetic field? I missed a 2 over here. এখানে একটা 2 ছিল, so I should write it. নিচে একটা 2 ছিল না, 2r cube ছিল, it was 2r cube. Look, 2r cube. So this will be therefore the total magnetic field due to the entire solenoid. This was due to a small element. Total magnetic field at capital P due to the entire solenoid. Due to the entire solenoid. পুরো সলিনয়েডটার জন্য কত হবে? Due to the entire solenoid, that will be B equals to integration of dB, or you may write integration of theta 1 to theta 2, right? Theta 1 was the angle on the left side, theta 2 was the angle of the right side, right end. So that is mu 0 ni by 2. It is sin theta d theta. Now integration of sin theta will yield a negative sign. That negative sign will be taken care within the limits. So it is mu 0 ni by 2, it is a negative of sin theta, negative of cosine theta. So that will be cosine of theta 1 minus cosine of theta 2. Cosine of theta 1 minus cosine of theta 2. So that will be the expression we obtain. So capital B equals to mu 0 ni by 2 cosine of theta 1 minus cosine of theta 2. So that is the expression that we obtained in this particular problem. I hope that you have understood it. আশা করা যায় তোমরা বুঝতে পেরেছো. So this is the expression that you have for a solenoid. Now if you look at your books and what is the direction? It is along the axis. Because for a circular conductor the magnetic field is along the axis. Last class পড়েছিলে in the last class? In the last class you know that for a circular conductor it was resolved into two components, along the axis and perpendicular to the axis. Perpendicular to the axis component got cancelled and only which component survived? Along the axis. So for any circular conductor, যে কোনো circular conductor এর জন্য magnetic field টা কোন দিকে হয়? The magnetic field is always along the axis, right? The magnetic field is always along the axis, right? And what is the direction of it? If you want to find the direction, it's very simple. Have a look over here. একটু ভালো করে দেখে নাও. ধরো এটা হচ্ছে সার্কুলার কন্ডাক্টরটা আর এটা হচ্ছে কারেন্টের ডাইরেকশন, অ্যান্টি ক্লকওয়াইজ সেন্স. সো ইউ জাস্ট ফোল্ড ইউর রাইট হ্যান্ড ইন দ্য ডাইরেকশন অফ দ্য অ্যারো. তোমার রাইট হ্যান্ডটাকে অ্যারো ডাইরেকশনে ফোল্ড করো. দ্য ডাইরেকশন অফ দ্য থাম্ব গিভস ইউ দ্য ম্যাগনেটিক ফিল্ড. সো লেট মি ড্র টু ডায়াগ্রামস. ওয়ান ইজ দিস and another one is this one. আরেকটা হচ্ছে এইটা in the clockwise sense. So for this one, for the anti-clockwise sense, you just fold your right hand in the direction of the arrow. তোমার ডান হাতটা অ্যারোটার দিকে ফোল্ড করো, and your nails মানে তোমার হাতের যে নখগুলো আছে, হাতের নখগুলো, the nails should be in the direction of the arrow. Nails should be in the direction of the arrow, and you fold your right hand. হাতের নখগুলো অ্যারোর দিকে দিয়ে ফোল্ড করো. Put your nails in the direction of the arrow and fold your right hand. So for the first case, the thumb is towards you. Thumbটা তোমাদের দিকে আছে. তার মানে the magnetic field is outside the plane of the paper. Magnetic field is outside the plane of the paper. And in this particular case, this second case, you put your fingers in the direction of the arrow. That is now the thumb is pointing inside the screen. এবার নিশ্চয়ই থাম্বটা ভিতর দিকে আছে, because right handটাকে তো fold করাতে হবে, ultimately you have to fold the right hand in the direction of the arrow, and right hand can fold only in one direction. ডান হাত তো একদিকেই fold করতে, ন্যাচারাল ফোল্ডিং, জোর করে fold করবে না, don't fold it forcefully, naturally কোন দিকে fold করে, you should fold right hand. Whenever I say fold right hand, that means that is natural folding. জোর করে অপোজিটে ফোল্ড করলে হবে না, you should not forcefully fold it in the opposite direction, you just fold it naturally you just fold it. So you see that now the thumb is inside the plane of the paper. So that is how you decide the direction, that whether it is outside or inside, but it is always along the axis. That is what we have seen in the last class. And you know that solenoid is composed of what? Solenoid is composed of many number of circular conductors. Solenoid কি দিয়ে তৈরি হয়? Solenoid is made up of large number of circular conductors. অনেকগুলো circular conductor মিলে একটা solenoid তৈরি হয়. So that is why it is always along the axis, because solenoid is made from what? From circular conductors only. So that is why the magnetic field is along the axis. Now here I would like to make a statement that in few of the textbooks you may find that here it is plus. এখানে প্লাস থাকতে পারে কোন কোন টেক্সট বইতে. The reason behind that one is কেন ওখানে প্লাস আসলো, because in few textbooks they didn't take this to be theta 2, so they have taken this one to be theta 2. অনেক বইতে এই অ্যাঙ্গেলটাকে theta 2 নিয়েছে. So basically then this angle becomes pi minus theta 2. মানে the angle which I call theta 2, that one now becomes pi minus theta 2. And that is why cosine of pi minus theta 2, you know it is minus cos theta 2. And there is a change of sign. So no need to worry about it. If in some of the textbooks you find it to be something different, no need to worry. যদি কোনো টেক্সট বইতে দেখো যে অন্যরকম আছে, চিন্তা ভাবনার কোনো কারণ নেই. You may get a plus sign over here. So you have to understand that their convention is theta 2 is different than ours. So you just stick to the convention that I have provided to you. So আমি যেটা প্রোভাইড করলাম তোমরা এইটার মধ্যে সীমাবদ্ধ থাকো, অসুবিধা হওয়ার কোনো কথা নেই. So there is no chance of any type of difficulty. So in any type of problem you just remember this, just এটাকে মনে রাখো যে কি বলছি আমি, that the angles are taken from all angles are taken in the clockwise sense. মানে আমি যা করেছি সবগুলো অ্যাঙ্গেল দেখো আমরা clockwise sense এ নিয়েছি. We have taken all the angles. You see this is theta 1, এটা theta 1 নিয়েছি, and from the same side we take it theta 2. মানে একটা এদিকে নিলাম একটা এদিকে নিলাম, not like that. I didn't take one in this side and another from the other side. দেখো এটা clockwise from the base and this is anti-clockwise from the baseline. So I have not done so. I have taken both of them, this one and also this one. I have taken both of them in the clockwise sense. So I have followed this convention. So that is why it is cos theta 1 minus cos theta 2. In the books it may be different, so no need to get confused. It's just the convention of thetas. Right. Now let us go for some special case. So the first case is that special case. That is the general expression. So one of the special case is that for an infinitely long solenoid, or when A is less the length of the solenoid, A is less than L. There are two cases. One is L is very large, the length of the solenoid is very large, or another case is that when the radius of the solenoid is very small in comparison to the length. When the radius of the solenoid is very small in comparison to the length, under that circumstances. So let us see what happens. তাহলে কি হচ্ছে সেটা দেখে নিই. Let me redraw the diagram. I just draw a rough diagram for your convenience. একটু বোঝার সুবিধার জন্য একটা ছোট করে ডায়াগ্রাম ড্র করে নিচ্ছি. I just draw a diagram over here. So you see that this one was my point capital P and this angle was theta 1. এখান থেকে একটা অ্যাঙ্গেল ছিল, এই অ্যাঙ্গেলটা ছিল theta 1 আর এই দিকের অ্যাঙ্গেলটা this angle was theta 2. Now over here you see that as for infinitely long solenoid, if I just try to increase this length, এই length যদি বাড়াতে থাকি, so then what will happen? This theta 1 will be decreasing, theta 1 টা বাড়তে থাকবে, and if I increase the length on this side, then theta 2 is increasing. যদি বাঁদিকে length বাড়াই, if I increase the length on the left side, theta 1 decreases, and if I increase the length on the right side, then theta 2 increases. So that means that for a long solenoid, theta 1 tends to 0 and theta 2, this one tends to pi. একটা tends to 0 হবে, একটা tends to pi হবে. তাহলে therefore B এর এক্সপ্রেশনটা কি হবে? So B equals to simply it will be mu 0 ni by 2, and here you will also have 1 plus 1. So this gets cancelled to give you B equals to mu 0 Ni. I hope that you are familiar with this expression from your higher secondary classes. হয়তো higher secondary class এটা দেখেছিলে. So this is the magnetic field due to a infinitely long solenoid. এটা infinitely long solenoid এর জন্য, because you know that cosine of 0 is 1 and cosine of pi is -1. So this one becomes 1 plus 1. তাই তো এটা -1 আছে এখানটা, this value is -1. So 1 plus 1 is 2, that gets cancelled with this and you get this one. The same expression also holds when A is less than L. What does it mean? That the radius of the solenoid is very small in comparison to the length. The same thing will be valid over here also. Have a look over here. This is the length of the solenoid and this is the radius. I show you that the radius of the solenoid is very small. Solenoid radius টা অত্যন্ত ছোট, সেটাই দেখাতে চাইছি আমি এখানটা। Suppose this one is the solenoid, এটা হচ্ছে solenoidটা, this one is the solenoid, this is the radius of the solenoid which is very small in comparison to the length. Are you getting it? এর length, এর এটা দেখো অত্যন্ত ক্ষুদ্র এর length এর রেসপেক্টে, এখানেও নাকি একই রকমের জিনিস হোল্ড করবে, here also the same thing will hold. This is just a matter of check, just একটু চেক করে দাও this, what is going on? So this angle is θ1, you understand, এখানে একটা অ্যাঙ্গেল তৈরি হবে, এতটাই ছোট ভালো হচ্ছে না, so it's very small, it's very difficult to draw. So this angle over here, এই অ্যাঙ্গেলটা হচ্ছে θ1, you understand, and this angle, you know, this angle is what? This angle is θ2. Now you see that as A becomes smaller and smaller, ভেবে দেখো এটা যত ছোট হচ্ছে, as A becomes smaller and smaller, that means what? This line will come closer, এই লাইনটা আরো ক্লোজ চলে আসবে, A becomes smaller and smaller, you see that θ1 will tend to 0, তখন θ1 কোনটা হবে? This is θ1 and this line will be θ2, right? You have to understand this. It will be not clear from the diagram because it is very small picture. তো খুবই ছোট আছে এটা, so এখান থেকে এটা বুঝতে হবে যে এটা যত ছোট হবে, more and more the lesser and lesser the value of this A, এই এটা যত ছোট হবে, lesser and lesser the value of this A, what will happen? This θ1 will tend towards 0, because এখানে θ1 এর ভ্যালুটা দেখো আর এখানে θ1 এর ভ্যালুটা দেখো, definitely the θ1 value has decreased মানে it is tending towards 0, and look at the θ2 over here and θ2 over here, so definitely this θ2 is more, এই θ2 টা অনেক বেশি আছে, বেশি মানে কি it is tending towards pi, more means it is tending towards pi, so θ1 is tending towards 0 and θ2 is tending towards pi, right? So the same thing happens over here. So for an infinitely long solenoid, or when the radius is very small in comparison to the length, I will be use this. Now infinite is a hypothetical concept. Infinite concept তো এটা একটা hypothetical. Infinite তো হয় না, it is not infinite. A very long length we call it infinite. So basically this condition refers to this mu 0 Ni by 2, and this is a very common expression that you will encounter during the classes of electricity. Electricity class এই জিনিসটা তুমি খুব commonly, very frequently you will encounter this, that A is very less than L. I hope that you have understood these very simple issues. আশা করি এই সিম্পল ইস্যুটা বুঝতে পেরেছো, এক্সপ্রেশনটা মনে রাখো। Let me go to the next case. Next case হচ্ছে P is at one end. P is at one end. P টা যদি কোনো একটা এন্ডে হয় তাহলে কি হবে? If this P is at one end of the solenoid, then what happens? Let me draw a diagram once again for it. আরেকটা ডায়াগ্রাম ড্র করে নিই। So it's drawn. So this is the P, right? And as you know that you have to join the two ends, দুটো end কে join করতে হবে. So this angle gives you θ1 and you have to join the other end also, এটাকেও join করতে হবে, and this angle gives you θ2. And definitely you find over here that your θ2 is nothing but pi by 2, right? So over here you see that what is actually going on is θ2 is pi by 2. So therefore B equals to, it is mu 0 Ni by 2, বাস আর কিছু তো হবে না, ও আরেকটা হবে তো cosine of θ1, because cosine of θ2 cos pi by 2, you know cos pi by 2 is 0. বলে গেল কি হলো? So P টা যদি একটা এন্ডে হয়, if P is at one end, so then what actually happens is that then one of the angle is 90 degree, and the last case is that P is at one end, P is at one end of a semi-infinite semi-infinite solenoid. At one end of a semi-infinite solenoid. So what is a semi-infinite solenoid? Semi-infinite মানে একটা end দেখতে পাচ্ছ, one end you can see, and that at that end there is P, and the other end you cannot see, মানে other end you cannot see, it is so long, এতটা লম্বা, অন্য এন্ডটা দেখা যাচ্ছে না। So লম্বা মানে কি? So this angle, so what will happen to that angle? So that theta 1 tends to 0. So as you are increasing this length, এই লেন্থটা যত বাড়াবে, as you are increasing this length, this theta 1 will be decreasing. So theta 1 tends to 0. এটা তো একটু আমি করে দিলাম, just now I have discussed that as it is of infinite length, theta 1 goes to 0 and theta 2 goes to pi. But here it is semi-infinite. মানে it means that one end is at infinity. একটা end দেখতে পাচ্ছ না, but you can see the other end. So theta 1 tends to 0. That means that B is equals to mu 0 ni by 2. So B equals to mu 0 ni by 2 because cos 0 is 1. But out of all this, the most important is this one, mu 0 ni, mu 0 ni. That is for infinitely long solenoid, or when the radius is very, very less than the length. That is what I call the infinite. Fine. But let me just show you a numerical example from here. একটা example আমি এখান থেকে দেখিয়ে দিচ্ছি, একটা very simple example. A standard solenoid of length 2 meter, a standard solenoid of length 2 meter and radius 4 centimeter, and radius 4 centimeter has 5,000 turns, A current of 1 ampere is passed through it. A current of 1 ampere is passed through it. A current of 1 ampere is passed through it. Calculate the magnetic field at any point inside the solenoid. Calculate the magnetic field at any point inside the solenoid. Calculate the magnetic field at any point inside the solenoid. Solenoid ভেতরে কোনো একটা পয়েন্টে ম্যাগনেটিক ফিল্ডটা বের করো। সো এখানেও একটা জিনিস দেখো, তুমি ক্লিয়ারলি বুঝতে পারছো that the radius is very, very less than capital L, because the radius is 4 centimeter, right? এখানে রেডিয়াসটা আছে 4 centimeter and length is 2 meter. Centimeter and meter means it is already there is a difference of 100 times. Centimeter meter মানে এখানে already 1000 times এর একটা ডিফারেন্স আছে, there is a difference of 1000 times, right? Because one is centimeter, another is meter, so there is a difference already of how much? 1000 of 100 times. So R is very, very less. So when R is very, very less, then you can simply use this expression, B equals to mu 0 ni. But while using this expression, you should be very much careful that n is not the total number of turns, but it is the number of turns per unit length. So it is 2500 per meter, right? n টা কিন্তু মনে রাখো, এটা total number of turns নয়, but it is the number of turns per unit length. So that is why 2500. Mu 0, you know the value of mu 0. Mu 0 এর value আমরা জানি, it is 4 pi into 10 to the power minus 7, and current will be also in SI, that is 1 ampere. So you just do this, and the answer for this is pi into 10 to the power minus 3 Tesla. We will be following the SI units always. So this was one of my tasks to show you, and that has been over. এবং সেটা আমরা করে ফেলি। So the next expression that I will be following over here is that, so next যে expressionটা আমরা করব, we know that any current carrying conductor produces magnetic field. যে কোনো কারেন্ট ক্যারিং কন্ডাক্টর একটা ম্যাগনেটিক ফিল্ড তৈরি করতে পারে। Any current carrying conductor can produce a magnetic field. This is what we know, all of us. Any current carrying conductor can produce a magnetic field, right? Current carrying conductors can produce magnetic field. That is what we know, right? আমরা জানি এটা, any current carrying conductor produces magnetic field. And so that is current and the magnetic field, they are related to each other. So wherever there is a magnetic field, there is some current type of behavior, and wherever there is a current, there is a magnetic field. So current and magnetic fields are related to each other, and that is why there is a mutual interaction between the electric field and the magnetic field. Electric field and magnetic field are not independent of each other, but electric field and magnetic field always interacts among themselves. Electric field and magnetic field যদি কোথাও একসাথে থাকে, if there is electric and magnetic field simultaneous action, if there is a simultaneous action of electric and magnetic fields, so they will interact with each other. তারা একজন আরেকজনের উপর একটা এফেক্ট ফেলবে, and that is why we will be discussing a topic over here, force between two current carrying conductors. Excuse me, force between two current carrying conductors. Force between two current carrying conductors. দুটো কন্ডাক্টরের মধ্যে কত ফোর্স থাকবে, ফোর্স বিটুইন টু কারেন্ট ক্যারিং কন্ডাক্টরস। দিস ইজ ভেরি ইন্টারেস্টিং। দেয়ার ইজ নো মেকানিক্যাল ফোর্স, কোনো মেকানিক্যাল ফোর্স এখানে নেই। দেয়ার ইজ নো গ্র্যাভিটেশনাল ফোর্স, নো মেকানিক্যাল ফোর্স, নো গ্র্যাভিটেশনাল ফোর্স, বাট ইয়েট দেয়ার ইজ এ ইন্টারাকশন বিটুইন দ্য টু কারেন্ট ক্যারিং কন্ডাক্টরস। তোমার কাছে শুধু সিম্পলি দুটো তার আছে, ইউ আর সিম্পলি টু ওয়্যারস, and some current is flowing through those wires, এবং সেই ওয়্যার গুলো দিয়ে কি হচ্ছে, কারেন্ট ফ্লো করছে। You have simply two wires, and through the wires current are flowing, but there is a force between them. তাদের মধ্যে একটা ফোর্স কাজ করছে, right? And that is what we are trying to find over here. And you should also understand that why there is a force between them. I hope that you know the expression of the force acting on a current carrying conductor. Current carrying conductor উপর যে ফোর্স কাজ করে সেটা আমরা জানি from the concepts of Lorentz force that you have studied in your higher secondary classes. So these are the two current carrying conductors. One of them is carrying a current I1 and another is carrying a current I2. One of them is carrying a current I1, another is carrying a current I2. The separating distance between them is, suppose, small a. This is the separating distance between them. This one I call it number 1 and this one is 2. Okay, here I am trying to find it for long wires. For long wires. I hope that you know the expression for the force acting on a current carrying conductor in a magnetic field. ধরো একটা magnetic field আছে, suppose this region there is a magnetic field B vector. Now if an electron enters within this magnetic field, a magnetic field এর মধ্যে, don't draw this, okay? This is just for your explanation. So there is a magnetic field over here, B vector, and there is a current, suppose electric field, like here you have an electric field over here. এবং এখানে ধরে নাও একটা ইলেকট্রিক ফিল্ড আছে, okay? So this is a magnetic field and here you have electric field over here. Okay, before doing this calculation, I think that it's better to show you the expression of the force acting on a current carrying conductor. Okay, force acting just on an electron, the force which is acting on an electron which is in a magnetic field, or the force acting on a current carrying conductor in a magnetic field. Before going into this particular deduction, এই ডিডাকশনটাতে যাওয়ার আগে আমার মনে হয় ওইগুলো একটু বের করে নেওয়া উচিত। I should find those expressions and then I must come back to this expression, এবং তারপরে আমি এটাতে ফেরত আসবো। I think that it would be better for you, for your better understanding, right? Those things you don't need to write, ওগুলো লেখার দরকার নেই, you have studied it in your higher secondary classes. Just I will come back to this discussion only, no need to cancel anything, কোনো কিছু কাটাকুটি করার দরকার নেই, no need to cancel anything, let it be like this, you just listen for the next 10 minutes. Next 10 minutes আমি কি বলছি সেটা একটু শুনে নাও just, okay? You just listen it for the next 10 minutes and then I will come back to this calculation, okay? So that's the idea, because the expression I know that it is known to you, that is q v cross b and then it is I dl cross b, but yet for my own satisfaction I will just recapitulate it once, because there is no harm in recapitulation. একটা জিনিস আরেকবার শিখলে একটা কোনো অসুবিধা তো কিছু নেই, just it will just take a 10 minutes of time and the understanding will be better, এবং এটা better understanding তৈরি হবে. So that is what I will do. I will do it, I will show you the basic expressions and then I will come back to this, okay? So let me just show you the basic expression first and then I will come back to this particular treatment. Fine. Let us write in this way: force acting on a current element, force acting on a current element in a magnetic field. Force acting on a current element in a magnetic field. So this has been already provided by Lorentz. So you know that এখান থেকে আমরা জানি the force acting so in your higher secondary classes you have studied about the Lorentz force. So from the concept of Lorentz force you know that the force acting on a moving charge, force acting on a charge q moving with velocity v, force acting on a charge moving with velocity v, that is given by F moving with velocity v in magnetic field B vector, moving with velocity v in magnetic field B vector. So what is the force? You know that the force is given by q v cross b, and this is what is called the Lorentz force. You know this expression, এটা জানো higher secondary class থেকে. This is the force acting on a charge q moving with velocity v in a magnetic field B vector. Now suppose we have a current carrying conductor. এবার ধরে নাও তোমার এখানে একটা কারেন্ট ক্যারিং কন্ডাক্টর আছে. সাপোজ ইউ হ্যাভ আ কারেন্ট ক্যারিং কন্ডাক্টর. কনসিডার a current carrying conductor, in which dq amount of charge crosses dl length of the conductor, dq amount of charge crosses dl length of the conductor, dq amount of charge crosses dl length of the conductor in time dt. dq amount of charge crosses dl length of the conductor in time dt. Okay, consider a current carrying conductor in which dq amount of charge crosses dl length of the conductor in time dt. So force acting on these charges, force acting on this dl element, এই dl এলিমেন্টের উপর কতটা ফোর্স কাজ করছে? What is the force acting on this dl element in the magnetic field? Now why the force is acting? Because this is, you should understand that electric and magnetic fields are related to each other. So wherever there is an electric field, there is a magnetic field. So electric field and magnetic fields are the manifestations of each other. যেখানে ইলেকট্রিক ফিল্ড থাকবে সেখানেই ম্যাগনেটিক ফিল্ড থাকবে, যেখানেই ম্যাগনেটিক ফিল্ড থাকবে সেখানেই ইলেকট্রিক ফিল্ড থাকবে. This has been understood from the different experiments. You put a charge, you pass a charge in a magnetic field, the charge is deflected from its pathway. ধরো একটা চার্জ তুমি নিলে, you take a charge q and you allow it to pass through a medium. একটা চার্জকে একটা মিডিয়াম দিয়ে তুমি পাস করালে, you pass a charge through a medium, the charge will just pass in its own trajectory. A straight line ওরা পাস করে যাবে, it will pass in the straight line. But if you put it in a magnetic field, যদি magnetic field এর মধ্যে এটা করো, so then it will not pass in a straight line, but it will follow a trajectory like this. So this trajectory means what? There is a continuous forcing on it. তাহলে এই ট্র্যাজেক্টরিটা মানে কি তার উপর কন্টিনিউ কেউ একজন ফোর্স দিচ্ছিল, দেয়ার হ্যাজ বিন সাম ফোর্সিং অন ইট, এর উপর ফোর্স এসছে, আর সেই ফোর্সটা কে দিয়েছে? দ্যাট ফোর্স ইজ গিভেন বাই ম্যাগনেটিক ফিল্ড, and that expression has been suggested by this Lorentz formula. So there is no proof of this one, so this has been put forward from the intuitions, this has been put forward from the manifestation of the results. So এই ফর্মুলার কোনো প্রুফ নেই, there is no proof of it, but this has been put forward from the experiences, from the regular experiences. So experience থেকে এই ফর্মুলাটা লোরেন্জ দিয়েছিলেন, this has been provided by Lorentz from his experiences, that Q V cross B. If a charge is placed in a magnetic field, its trajectory is deflected. Meaning it will not go into the straight line, but its trajectory is deflected. And this deflection is due to what? This is due to the presence of the magnetic field. Once you remove the magnetic field সরিয়ে দাও, there is no such force. So some people write it FM also, F magnetic force. তাহলে DL এলিমেন্টে কত ফোর্স কাজ করবে? So DL element, so I write it DF. What is the amount of charge? That is dq. And the velocity, can I write it dl by dt? Velocity কে কি dl by dt লিখতে পারি আমি? Can I write velocity to be dl by dt? Definitely you can write it dl by dt. তুমি অবশ্যই dl by dt লিখতে পারো, because dl distance is crossed in a time dt. তার মানে velocity কত? dl by dt. Now if you take this dq by dt together, এটা যদি একসাথে নিতে পারি dq by dt together, so dq by dt you know it is nothing but current. So here you get the expression I dl cross b. So this is how you obtain the expression of I dl cross b, which you have also used in your higher secondary classes. So that was my actual goal, to show you the force acting on a current carrying conductor placed in a magnetic field. So if a charge moves in a magnetic field, একটা charge যদি magnetic field এ move করে, if a charge moves in a magnetic field, then it experiences a force which is given by this expression. And if instead of charge you have a conductor, current carrying conductor, so then the force acting on the conductor is I dl cross b. But provided there must be some magnetic field, একটা magnetic field থাকতে হবে. So what is the issue now? So now the issue is that you have a magnetic field and you have a current carrying conductor. So that conductor will experience some amount of force. তাহলে এখন তোমার কাছে বেসিক্যালি কি আছে? তোমার কাছে একটা কন্ডাক্টর আছে, you have a conductor and you have a conductor which carries current, you have a conductor which carries current, and you have a magnetic field. So that conductor will experience some magnetic force. তো সেই কন্ডাক্টরের উপরে একটা ফোর্স কিন্তু কাজ করবে, যার এক্সপ্রেশন হচ্ছে এইটা. The expression is given by this. I hope you have understood, right? Excuse me. Now let us come into the treatment. That is our main intention over here. So next আমরা যে ট্রিটমেন্টটা করব ওটাই আমাদের মেন ইন্টেনশন, and that intention is force between two current carrying. I put up the heading once again. Force between two current carrying conductor. You come back to the treatment of force between two current carrying conductors, and here I will take as long wires. Force between two current carrying conductors, I will take it to be long wires. Long wires has been studied on the last class, so this is what I am going to do next. So what are my wires? So these are my two wires. You suppose two long wires, straight wires. I have taken straight wires because I know the expression for them. এই expression গুলো আমার জানা আছে, সেজন্য আমি এইটা নিলাম. This is my I1 current carrying element, this is my I2 current carrying element, these are my two current carrying elements. The separating distance between them is a. এদের মধ্যে separating distance-টা যেটা আছে সেটা হচ্ছে a. This is my coil number 1, এটা হচ্ছে coil 1, and this is my coil number 2. Let me just put a basic introduction. একটা basic introduction আমরা লিখছি. You know the goal of it. আমরা এখানে কিন্তু কোথাও কোনো magnetic field নেই. There is no magnetic field over here. So you may ask me that, sir, why they will experience a force? কেন force থাকবে? I will explain you. There is no external magnetic field, yet there is a force between them. Why? So I will be explaining. Let us consider two current carrying. Let us consider two current carrying parallel wires. Two current carrying parallel wires carrying current I1 and I2. carrying current I1, I write it in this way only, I1 and I2, because I don't have any option to write it in the subscript, but these are actually subscript. The way I have written over here, I1 and I2. So carrying current I1 and I2 and separated by distance A, and separated by distance A, and they are separated by distance A, right? Let us consider two current carrying parallel wires carrying current I1 and I2 separated by distance A. Now the next question is that there is no magnetic field, but you know that in order to experience a force, একটা কন্ডাক্টরকে ফোর্স এক্সপেরিয়েন্স করতে হলে, if a conductor has to experience force, then there must be some magnetic field. সেখানে একটা magnetic field থাকতে হবে. There must be a magnetic field. So the next idea is that the magnetic field, who produces the magnetic field? You see, magnetic field at the position of wire 2 due to wire 1. Magnetic field at the position of wire 2 due to wire 1 is magnetic field at the position of wire 2 due to wire 1 is how much? Magnetic field at the position of wire 2 due to wire 1. So in wire 1, this wire 1, this produces a magnetic field. Definitely you know it, the expression of it from your previous classes. The expression is mu0 I by 2 pi a. মনে পড়েছে এরকম একটা এক্সপ্রেশন ছিল। Just this one will be I1. Magnetic field at the position of wire 2, এই wire 2 এর এই পজিশনে ম্যাগনেটিক ফিল্ড কত তৈরি হয়েছে? What is the magnetic field produced? That is definitely mu0 I by 2 pi a. এক্সপ্রেশন করে দিয়েছি আমরা আগে। তাহলে এখন তোমাকে বুঝতে হবে, now you have to understand that this I2 is under the effect of a magnetic field, and wherever there is a magnetic field, there is a force acting on the conductor given by this expression. যেখানেই ম্যাগনেটিক ফিল্ড থাকবে সেখানেই কি থাকবে? wherever there is a magnetic field, there will be a force acted on upon that conductor. I hope that you have got it now. একটু আগে যেটা বলেছিলাম, previously whatever I have said, there is an external magnetic field and there is a current carrying conductor, so the conductor will experience some force. But here there is no external field, এখানে কোনো external field নেই, but ফিল্ডটা কে তৈরি করেছে? Who produced the field? The field is produced by another wire. So another wire produces a field, and under the action of that magnetic field, the second wire will experience some force, এবং second wireটা একটা force অনুভব করবে. So who is the source over here? The source is the first coil, and what is the effect? The effect is on the second coil, right? The cause is the first wire and the effect is produced on the second wire. So that is how the magnetic field at the position of wire 2 due to wire 1 is given by this. And what is the direction of this magnetic field? I call it B1. It is inside the plane of paper. Inside the plane of paper. Right. আচ্ছা, কি করে বুঝলাম ইনসাইড দ্য প্লেন অফ দ্য পেপার হবে? হাউ ডু আই আন্ডারস্ট্যান্ড? সো দিস ইজ another interesting thing that you should understand, that why the magnetic field is inside the plane of paper. So when is the magnetic field inside the plane of the paper and when the magnetic field is outside the plane of the paper, that should be properly understood by you. এটা কিন্তু তোমায় properly বুঝতে হবে যে ইনসাইড হবে না আউটসাইড হবে। So how to understand this? So the rule is that So the rule for this one is that your nails, তোমার যে নখগুলো আছে, the nails of your right hand should be along the direction of the current. তোমার যে রাইট হ্যান্ডের যে হাতের নখগুলো আছে, the fingers of the right hand, the open end of the fingers, মানে আঙ্গুলের যে খোলা দিকগুলো, মানে যেদিকে নখ আছে, the nails, the end in which you have nails, so that should be in the direction of the current. মানে সেটাকে আমি করলাম উপর দিকে, so my hand should be in the upward direction. So right handটাকে কোন দিকে রাখতে হবে? In the direction of the current, so that is why I put it in the upward direction. Understood? In the upward direction. And then I need to fold the right hand towards the point where you have to calculate the magnetic field. তারপরে তোমাকে রাইট হ্যান্ডটা ফোল্ড করতে হবে, ন্যাচারাল ফোল্ডিং, the right hand folds towards the left, রাইট হ্যান্ডটা বাঁ দিকে ফোল্ড করে। বাট আমাকে কোন দিকে ফোল্ড করতে হবে? In which direction should I fold? I have to fold it in the direction towards the point at which I am interested to calculate the magnetic field. মানে in this case I am interested to find the magnetic field at this point. So I have to fold my right hand towards that red dot. তার মানে আমাকে রাইট হ্যান্ডটাকে কিন্তু রেড ডটের দিকে ফোল্ড করতে হবে। বাট ইউ সি দ্যাট দিস ইজ নট পসিবল, এটা তো হচ্ছে না। কেননা নর্মালি তুমি যদি ফিঙ্গার গুলো উপর দিকে রাখো, ইফ ইউ পুট দ্য ফিঙ্গার্স in the top direction, because fingers should be in the direction of the current. আঙুলগুলো তোমার কারেন্টের দিকে থাকতে হবে। The fingers should be in the direction of the current. That is okay, that's fine. At this position the thumb is towards you. বুড়ো আঙুলটা নিশ্চয়ই তোমাদের দিকে আছে। The thumb is towards you. And now you need to fold the right hand. তোমার right hand fold করতে হবে কোন দিকে? Towards the point in which you are interested. That is towards the red dot. But fold করতে পারছো না। You cannot fold it. You cannot fold forcefully. Forcefully fold করতে বলা হয়নি. You are not asked to fold forcefully. You have to fold naturally. Naturally যেদিকে fold করে সেই দিকে fold করতে হবে। তাহলে হচ্ছে না। তাহলে কি করতে হবে? You have to flip your right hand. তাহলে ডান হাত থেকে উল্টে দিতে হবে এখন। মানে বুড়ো আঙুলটা নিচের দিকে চলে যাবে। The thumb will be in the downward direction. You have to flip the right hand. Right handটাকে flip করতে হবে, ঘুরিয়ে দিতে হবে right handটাকে। ফিঙ্গার গুলো উপর দিকেই থাকবে। The fingers will be on the top. The fingers will be on the top, and now you see you can flip the right hand. Sorry, you can fold the right hand. তুমি right hand এখন fold করতে পারছো, provided your thumb is pointing towards the screen. এখন থাম্বটা কিন্তু স্ক্রিনের দিকে পয়েন্ট করবে, not towards you. Please listen to my words and do exactly what I say. Then only you will understand the things, and this will be interesting to you. Otherwise, not. আমি আবার বলছি, I repeat once again. Your fingers and the nails should be in the direction of the current. Do it. করলে the right hand should be folded naturally towards the point at which you have to calculate magnetic field. Right handটা naturally fold করতে হবে কোন দিকে? যেই দিকে তোমার ম্যাগনেটিক ফিল্ডটা বের করতে হবে, মানে রেড ডটটার দিকে। In this case you cannot fold it because right handটা কোন দিকে fold করছে? It is folding towards the left. Right hand কোন দিকে fold করে? Right hand সবসময় লেফট এর দিকে fold করে। But we are not interested. Our point is in this direction. Our point is on the right. So that is why you have to flip the right hand. Right handটাকে ঘুরিয়ে নিতে হবে। মানে nails গুলো উপরেই থাকবে, nails and fingers are on the top, but the thumb is now towards the screen. বুড়ো আঙুলটা স্ক্রিনের দিকে আছে। এই অবস্থায় দেখো fold হচ্ছে। Now you see that you are able to fold your fingers towards that red dot. তুমি fold করতে পারছো এখন, natural folding. And the thumb gives you the direction of the magnetic field. Thumb তোমাকে ম্যাগনেটিক ফিল্ডের ডাইরেকশন দেবে। The thumb gives you the direction of the magnetic field, and it is in which direction? It is inside the screen. Thumbটা কোন দিকে আছে রে? Thumb is in which direction? The thumb is inside the screen. The thumb is inside the plane of the paper. The thumb is inside the plane of the paper. That is what we want to say over here. That is why I have written inside the plane of paper. So this is how you have to find the magnetic field due to a straight conducting wire. So inside the plane of the paper, I cannot do so because this is a two-dimensional geometry, but I mark it in this way. So এটা হচ্ছে direction for this B1, right? So the second wire experience a magnetic field. তার মানে second wire এর মধ্যে একটা magnetic field আছে. The second wire experiences a magnetic field, and that magnetic field is what? It is B1 inside the plane of the paper. পেপারের বাইরের দিকে. If it is outside, then I would have given it like this, outside the plane of the paper, মানে towards us. If you hold a pen over here, the pen should be directed inward. ভেতর দিকে থাকবে পেনটা। So that is the direction of the magnetic field. Now, what happens to this I2? So a small element of this I2 will experience a force how much? Suppose here I consider a small element of this one. This is DL2. এটাকে আমি বলছি DL2. তাহলে এখানে লিখছি the force acting on an element DL2 the force acting on an element DL2 of the second wire due to the magnetic field of the first. Due to the magnetic field of the first, the force acting on an element DL2 of the second wire due to the magnetic field of the first, due to the magnetic field of the first, মানে কোনটা? B1. So the magnetic field is provided by whom? It is provided by the first one. And who experiences the force? The second one. মানে এখানে কোনো external magnetic field নেই. Here there is no external magnetic field. The magnetic field is due to whom? It is due to the first one. And now due to the Lorentz force, the second will definitely experience a force. And that force, if I call it df, আমি যদি সেটাকে df বলে থাকি, তাহলে সেটার এক্সপ্রেশনটা কত হবে? The basic expression is I dl cross b. Who gives the magnetic field? 1 gives the magnetic field, B1. On whom? On the second conductor. So that is why I2 and dl2. And definitely the angle between, so this is simply I dl2 B1. Because B1 and dl2 are at right angles to each other. B1 টা কোন দিকে আছে? B1 is inside the plane of the paper. B1 is inside the plane of the paper. মানে এই পয়েন্টে একটা পেন ধরো. At this point you just hold a pen. So what is the angle between the pen and this black line? This black line is the direction of dl2. Black line টাই হচ্ছে dl2 এর direction. So black line and you hold a pen over here. So তাদের মধ্যে angle কত আছে? So definitely it is 90 degree. So sin 90 is 1. So that's why it is I dl2 B1. এখানেও একটা ডাইরেকশনের ব্যাপার থাকবে. Here also there is a direction and that direction is towards where 1. That direction is towards where 1. This is left to you as a task. এটা তোমাদের কাছে টাস্ক হিসাবে আমি দিলাম. This is a task to you. This magnetic, this direction is this way. So এই দিকে আছে এটা. Okay. So this is the direction of the force F vector. এটাও কি করে বের করেছি? This one also I have done by the same rule that I have been following. এখানে কার উপর করতে হবে? Here you have to do it along dl cross b1. মানে you have to put your right hand along dl and fold it along b1. যে কোনো ক্রস প্রোডাক্টের রুলই হচ্ছে for any cross product a cross b, the rule is that you have to put your fingers of right hand, right হাতের ফিঙ্গার্স গুলো a এর দিকে রাখো. You put the fingers of right hand in the direction of a and fold it in the direction of b. এবং তারপরে b এর দিকে fold করো, fold it along b. The thumb gives you the direction. So this is left to you as a task. You people can definitely do it. তোমরা definitely করতে পারবে, but don't try to do it on a paper. Try to do it on a 3-dimensional geometry. Take 3 or 4 pens and try to do it and think yourself. 3-4টে পেন নিয়ে নিজেরা ভাবনা চিন্তা করে তারপরে এটা করো. I know you have done it in the higher secondary, but your understanding, there is a lack of understanding of most of the students during the higher secondary days. As I have come across through the different years, I have found it that there is a lack of experience. So you just think it yourself. I have give you the methodology. প্রত্যেকটা methodology বলে দিয়েছি. I have provided you the direction of B1. B1 এর ডাইরেকশনটা আমি বলে দিলাম কি করে বের করতে হয়. So B1 is inside the plane of the paper and this dl vector you can find the direction of it along the black line. So now what will be the direction of the F vector? It is inside like this. So I have said it is inside. Now it's your task. It's your task. এটা এইটুকু তোমাদের কাজ থাকলো যে এফটা যে সত্যি ভেতর দিকে, দেখো দুটোই হবে, আইদার ভেতরে হবে নয়তো বাইরে হবে. This F will be either inside or outside. So it is really inside. That is what you need to verify. So towards where 1. That's fine. So what is the force experienced by the second wire per unit length? So the force experienced by the second wire, force experienced by the second wire per unit length, force experienced by the second wire per unit length due to the first. Force experienced by the second wire per unit length due to the first wire is, force experienced by the second wire per unit length due to the first wire is how much? Per unit length মানে হলে কি হবে? For per unit length what will happen? So for per unit length this dl will be just divided. dl length এটা. This is the force for dl length. For per unit length it will be how much? So dl will be not there. Per unit length. Force experienced by the second wire per unit length due to the first is I2 into B1. So that will be simply mu 0 I1 I2 divided by 2 pi a. So this is the experience of the force experienced between two current carrying conductors. This is the force experienced by between two current carrying conductors. This is the force experienced between two current carrying conductors carrying current I1 and I2 separated by a distance a. And the direction of this one is towards the first one. towards the first wire, মানে সেকেন্ড ওয়্যারের উপর যে ফোর্সটা কাজ করছে সেটা ফার্স্ট ওয়্যারের দিকে। তার মানে এটা কি, ইট ইজ ডেফিনেটলি অ্যাট্রাকটিভ। The first wire is attracting the second. It is attractive in nature. Force experienced by the second wire due to the first. Second wire টা force experience করছে কার জন্য? Due to the first. প্রথমটার জন্য। কোন দিকে? Along the first wire. So that is why it is attractive in nature. That's it. Now here we would like to just mention 2 points. দুটো পয়েন্ট করে দিচ্ছি। Similar expression can be found for the force acting on the second due to the force acting on the first due to the second. একই রকমের এক্সপ্রেশন বের করতে পারো। Similar expression can be found for the force acting on the first due to the second. আর নাম্বার 2 টা হচ্ছে, if the direction of the currents are opposite, you see that here the currents are in the same direction. If the direction of the currents are opposite, then the force would be repulsive. If the direction of the currents are opposite, then the force would be repulsive. Directionটা যদি অপোজিট হয় তাহলে কিন্তু ফোর্সটা রিপালসিভ হবে। If the directions are opposite, then the force will be repulsive in nature. এখানে একটা কথা লিখে রাখতে হবে, let us consider two current carrying parallel wires carrying current I1 and I2 in the same sense, in same direction. In the same direction, you should mention it. Carrying currents in the same direction, because if it is in the opposite, then there will be repulsion, right? And this expression is true now for any current carrying conductors. This is the force acting per unit length between two current carrying conductors. দুটো কারেন্ট ক্যারিং কন্ডাক্টরস এর পার ইউনিট লেন্থে যে ফোর্স কাজ করে সেটা হচ্ছে এইটা। The force acting per unit length between two current carrying conductors is given by this. You remember এটা কিন্তু per unit length. And this expression will be used in my next treatment where I will be considering the circular conductors. Next কেসে আমি যেটা করব সেটা হচ্ছে আমি সার্কুলার কন্ডাক্টর আমি কনসিডার করব। Force between two current carrying coaxial coils. This is my next heading. Force between two current carrying coaxial coils. Coaxial, you understand? একটাই axis. Force between two current carrying coaxial coils. So here I will consider two coils. This is a coil and this is another coil. Okay. But in order to make my diagram clear, I will just draw this horizontal line. A diagram, and this is the axis, coaxial. একটাই axis এর উপরে আছে. They are having same axis. Instead of making the diagram clumsy, diagramটাকে clumsy না করে আমি শুধু কি করব, I will draw only what? I will draw only this horizontal line. আমি শুধু এই horizontal লাইনটাই টানবো, এই কয়েলগুলো আমি আর ড্র করব না। I am not going to draw the coils, okay? Just to make the diagrams clear. So what should I do? So this is my common axis. এটা হচ্ছে common axis টা। এটা হচ্ছে একটা coil, this is one of the coil, and this is another coil. এটা হচ্ছে আরেকটা coil. So these are the two coils over here. So এই হচ্ছে দুটো coil আমাদের কাছে। These are the two coils. Let me join the two end points. দুটো end point join করলাম। I join the two end points over here. Okay, that will be sufficient. The radius of this coil is A1. এই coilটা radius টা আমি ধরে নিচ্ছি A1 is the radius of this coil and the radius of this coil is A2. So this difference distance, তাহলে এই দিকটাও তাই হবে, this is A2 and this is A1. So this difference will be definitely A2 minus A1. তাহলে এইটুকু জায়গা হচ্ছে A2 minus A1. This difference is A2 minus A1. And the separating distance between the two coils, perpendicular distance is X. This distance is X. This one is P, this one is Q. This one I call the coil 1, এটা coil 1 টা, this is my coil 2, and this is the axis of the coil. এটা হচ্ছে coil এর axis. This is the axis of either of the coils. You need to find the force between these two current carrying coils, because just now you have learned, একটু আগেই শিখেছো, যেখানেই কারেন্ট ক্যারিং কন্ডাক্টরস থাকবে, wherever there will be a current carrying conductor, there will be magnetic fields, and due to the presence of the magnetic field there will be force on one another. যেখানেই কারেন্ট থাকবে সেখানেই ম্যাগনেটিক ফিল্ড থাকবে, and these magnetic fields will experience force on the current carrying conductors. So definitely the forces are definitely present over here. So definitely এখানে ফোর্স কিন্তু তোমার আছে, you have some amount of forces. So let us now calculate this. একটু ক্যালকুলেট করা যাক। Let us consider two coaxial coils of radius A1 and A2, of radius A1 and A2, carrying currents I1 and I2 in the same cells. Okay, I put it in the same cells, carrying current in the same cells, and separated by distance, how much? X. Separated by distance X. This is the introduction. Now the force acting per unit length, the force acting per unit length of coil 2 due to coil 1, the force acting per unit length of coil 2 due to coil 1 is how much? Mu 0 I1 I2 divided by 2 pi a. Just now we have found out the expression. Force acting per unit length of coil 2 due to coil 1. Force acting per unit length of coil 2 due to coil 1. It is per unit length. And you know that if the currents are in the same sense, it is attractive in nature. So attractive মানে কোন দিকে? Due to coil 1. তার মানে কি? Coil 1 টা কি করবে? The coil 1 will so it will be in which direction? The force acting per unit length. Okay, let me just change it. এই জায়গাটা একটু চেঞ্জ করে নাও। The force acting per unit length, and এটা অফ হবে না, এটা অন হবে, সরি মিস্টেক, স্লাইট মিস্টেক। Force acting per unit length on coil 1 due to coil 2. The force is acting on coil 1. Force টা কার উপর অ্যাক্ট করছে? The force is acting on coil 1 due to coil 2, and you know that the force is attractive. So that is why the force should be along this direction. তো সেই জন্য ফোর্সটা এইদিকে হবে, মানে কোন দিকে? along PQ. Got it? Force acting on coil 1 due to coil 2. Who is the force? Force টা এখানে coil 2, so it will be towards coil 2, attractive. Force acting on 1 due to 2, and it is attractive, so it will be towards 2, that is along PQ. This is the force acting per unit length. Now you see that this force can be resolved into two components. এবার এটাকে তুমি দুটো কম্পোনেন্টে রিজলভ করতে পারবে। You can resolve it into two components. That's very obvious. This can be resolved into two components. What are those? Number one, excuse me, this angle is theta, suppose. So you can resolve it along this direction. Eta ekta theta hobe. This is f cos theta, which is perpendicular to the axis, because this is the axis. This is perpendicular to the axis. If eta theta hole eta theta hobe. One is cos theta. Cos theta is perpendicular to the axis, and this one will be sin theta. Then eta hoye jabe sin theta. This is along the axis. So cos theta is perpendicular to the axis. One is f cos theta perpendicular to the axis, which gets cancelled. I will show you, which gets cancelled when you integrate over the entire loop. When we integrate cancels, when we integrate over the entire loop, which gets cancelled when we integrate over the entire loop. আর আরেকটা হচ্ছে the another one is f sin theta parallel, this is the symbol of parallel to the axis, which gets added up when we integrate over the entire loop. Please write it. So one is f cos theta, one is f sin theta. Now why such things happens? Because you see that the similar thing can occur on the right side also. ডান দিকেও একই রকম হবে. You can resolve it into two components. One is this component, another is this component. And here also you can resolve into two components. One is this, another is this. So obviously you see that this component and this component gets mutually cancelled from the opposite side. এই দুটো component cancel out হয়ে যাচ্ছে because they are equal and opposite. So this gets cancelled and this type of components are added up. Sin theta components will added up হবে, the sin theta components will be added up and the cos theta component gets cancelled when you consider the entire loop. তুমি তো শুধু এন্ডটা নেবে না, you are not going to consider only the end, you will consider the entire circumference of it. শুধু তো end নেবো না, I show you that the end gets cancelled and similarly the others will also get cancelled over here. একই রকম ভাবে বাকি জায়গাগুলো cancelled হয়ে যাবে. So whatever we find over here is that the cosine theta gets cancelled and the sin theta will be surviving. So what is the total force acting? So the final part, therefore, the total force acting on coil 1, total force acting on coil 1 due to coil 2, total force acting on coil 1 due to coil 2. Previously what did I find? Only per unit length. একটু আগে কি করেছিলাম, শুধু পার ইউনিট লেংথ বের করেছিলাম, পার ইউনিট লেংথ। বাট নাও এন্ড where from did I borrow the expression? This expression I have borrowed from here, এখান থেকে নিয়েছিলাম। বাট এবার আর শুধু পার ইউনিট লেংথ না, টোটাল ফোর্স অ্যাক্টিং অন কয়েল 1 ডিউ টু কয়েল 2, নট পার ইউনিট লেংথ, টোটাল। সো টোটাল ফোর্সটা কত হবে? সো দিস ওয়ান আই রাইট ইট ইজ ইকুয়ালস টু, ফার্স্ট অফ অল which component survives? f sin theta will survive and total length is what? 2 pi a1. total lengthটা কত হবে? ডেফিনেটলি 2 pi a1 হবে, তাই তো? The total length will be how much? That will be 2 pi a1. The total length of coil 1 is how much? Coil 1 এর total length কত? It is definitely 2 pi a1. So that is how you get the expression. বোঝা গেল নিশ্চয়ই? I hope that you have got it and you have understood it properly. তাহলে f এর এক্সপ্রেশন বসাও। f এর এক্সপ্রেশন হচ্ছে μ0 i1 i2 divided by what? μ0 i1 i2 divided by 2 pi, এখানে 2 পাই আমি কি লিখেছি a। আচ্ছা এটা কি? এখানে a বলে তো কিছু নেই, সো देयर ইজ নাথিং কল্ড a ওভার হিয়ার, देयर ইজ নাথিং কল্ড a, আই শুডন্ট রাইট a, এখানে a লেখা উচিত না। a ইজ দ্য ডিসটেন্স বিটুইন দ্য টু এলিমেন্টস, দ্য ডিসটেন্স ইজ pq। এই এলিমেন্ট থেকে এই এলিমেন্টের ডিসটেন্স কত? হোয়াট ইজ দ্য ডিসটেন্স বিটুইন দিস টু এলিমেন্টস? ইট ইজ pq। সো দ্যাট ইজ ওয়াই 2 পাই pq, আমাদের 2 পাই pq লেখা উচিত এখানে। সো আই শুড রাইট 2 পাই pq, μ0 i1 i2 divided by 2 pi pq. What is sin theta? From the diagram থেকে sin theta কত আছে? Perpendicular by hypotenuse, লম্ব by অতিভুজ, perpendicular by hypotenuse মানে x by pq. Again you write x by pq and it is 2 pi a1. But what is the value of pq square from the diagram? From the diagram pq square is a square plus x square plus a2 minus a1 whole square, right? x square plus a2 minus a1 whole square, right? So Pythagoras theorem, just I apply Pythagoras theorem, you see what happened? x square plus a2 minus a1 square, Pythagoras theorem apply করেছি। Got it? So this one, so 2 pi and 2 pi gets cancelled, so μ0 i1 i2 a1x divided by pq square. pq square is x square plus a2 minus a1 whole square. So I think that this is the expression for the force acting on coil 2 due to coil 1, total force. And what is the direction? This direction is along the axis. Why along the axis? Because along the axis component is present and other component is cancelled. এই যে কোন কম্পোনেন্টটা থাকে শুধু parallel to the axis, which component is present along the axis or parallel to the axis? Because এইটা তো ক্যান্সেল হয়ে গেছে, cosine theta gets cancelled and which survives? Sin theta, which is parallel to the axis. So since the parallel component is present, so that is why the force acting on coil 1 due to coil 2 is this one along the axis. এবং সেটা কত হলো, এইটাই হলো, and this is along the axis, right? So this is the expression that we get in this particular treatment. এটা আমরা এখানে পেলাম। এখান থেকে আমি তোমাদেরকে একটু টাস্ক দেবো। From here I will give you a task which can be a question at the time of exam, পরীক্ষাতে আসে। Maximum force. What is the maximum force acting? Maximum force. What is the condition for this force to be maximum? So for maximum force, you may set df dx is equals to 0. That is, what should be the separating distance such that the force is maximum? So you do this, eta korte korte jao, you will get x equals to a2 minus a1, right? And if you plug in this value on the expression of f, then you will get f max. তাহলে তুমি এখান থেকে f max টা পেয়ে যাবে। The value of f max is mu 0 i1 i2 into a1, mu 0 i1 i2 into a1 divided by 2 times of a2 minus a1, right? Mu 0 i1 i2 into a1 divided by 2 times of a2 minus a1. So you get the expression of the maximum force from here. So এটা হচ্ছে কন্ডিশনটা, this is the condition, and if you plug in this value of x, x এর এই ভ্যালুটা যদি এখানে বসিয়ে দাও, if you plug in this value of x over here, then you will get f max. তাহলে তুমি f max টা এখান থেকে পেয়ে যাবে। So these are the things that is given to you as homework, and you are requested to go through the tasks. So যেইটুকু টাস্ক তোমাদেরকে দিলাম, এই টাস্কগুলো ভালো করে দেখবে, পড়বে, go through the tasks, and you will definitely understand the issues that is going on in this particular type of treatments.